Okay guys, so let's try another question. Here is a question. This case, the electric field lines for the pair of charges shown. Okay, so before this we did we had a dipole configuration, right? So two charges with unequal sign, two charges of the same magnitude with unequal sign. This time let's do this. There is this charge Q. Maybe I'll write this name inside so it's easy for space. So we have some Q charge here, and then we also have another charge, another Q charge Q. One look bigger than me, smaller. Let's make this equal, okay? So kind of, so you try to make as equal as possible, okay? So both of these charges have the same magnitude and same sign, okay? So both of these are positive charges here. So please try drawing electric field lines for this configuration of charges, okay? Take some time. And you know, if you didn't get it, if you don't get it right, that's totally fine. We can work it together. Okay, so how far did you guys get? So first and foremost thing is, let's say we know charge originates at positive charge. Both of the charges are positive, so that's the not the problem, but okay, so we have to think about it. That's one thing. Another thing is, these are like charges. They have the same sign, so they also repel, okay? They repel, they don't like to come close to each other, which means the field also, you know, these field lines should also, they will also try to repel, okay? So they don't want to try to come close to each other. So it means, okay, so let's see. We know this is the farthest end of the charge, so we can start drawing. So okay, the charge, you know, field lines originates from positive charge, so it could go like this, okay. So we could also have the same thing here, goes out here. So maybe another line would be something like, you know, little, sorry. I mean to make that more curved. So the curve won't be like when you had just single charge, right? That's because this charge influenced this charge, right? So the line may go something like this. Same thing should happen here also, this side. Another line here may be like this, right? This line is bending away from this guy, that's why this was initially, it was like this, it would be like this if it was, you know, if this charge q was left by itself, and if we did not have this, okay, it would be like along this line. Okay, so maybe it would be like this, but because of this, now it's bending. Okay, so to make equal length, that's okay. So same thing here. Okay, so if we keep doing here, then we can kind of see, okay, it's gonna be like this here, same thing here. This field, you know, the original line that was like this, it's gonna again bend, so again we do the same thing here. And then we have here, okay, so basically, so and maybe we may have one or two here, or maybe many, but we aren't gonna draw all of those. This was originally going like this, but it's gonna bend, right? So originally going like this, but it's bending. Okay, same thing about here, like that, like this. Okay, so you see, basically you can draw more here. They get closer and closer, but they don't meet. Okay, so that's important. So you see, this space is pretty much now gap, right? So we don't have any fill lines here because these two charges are of equal magnitude. Okay, so yeah, we can keep drawing it, but that's gonna take forever. If you like to do it, you can, but I think this is sufficient. All right. Okay. So this is for the positive charge, you know, a pair of charges with equal sign, right? Sorry, same sign. In this case, we have positive charge. What do you think would happen if we have negative charges, guys, here? So right now we have a positive. Let's say we make it negative. How would this change here? Give a thought. Think about this. Negative charge equal magnitude, but equal same sign but negative. Okay, so and the thing we know is the field line begins and ends at negative charges, so arrow must be pointing towards the charge, but other than that nothing should really change, right? Because see, the only thing that would change if we had this, you know, if we replace this pair of charges with the negative pair of charges, then just this arrow, instead of going out, right, they would be pointing in because the field line must end at negative charges. Okay, so that's something you can try on your own. We'll not do it here. Okay guys, so here is a question. I may have to draw this So what combination of charges would generate electric field lines that look like this? Okay, so the line is like this. Let me try to draw it here. This red and the blue charge combination, but I'll draw it. It doesn't matter which color is which. Right? So let's. Okay, I'm gonna draw this as that red as a black here. Okay, guys. We have some charge combination here. And then we have another charge combination here. Okay, and the lines are going, one line going from there, center over there, and then there is also another line coming to this charge here, and then the line going out, and then the other line is, let's try to draw like that. Going like that. Okay, so here going out, oops, That's way too different. Okay, so like that, and then there are this way, that line going that way, and then there is one more line going that way. So it's important these lines, they don't intersect anywhere. Okay, so that part is important. And then we got other line going like that, like that, and then like that. Okay, so the question is this: what combinations of charges would generate electric field lines that look like this, look like shown above. Okay, alright guys, so try to see if you can figure this out, like what combination of charges. Earlier, remember, we had the charges and we draw the field lines. Now we have a field lines. Now we have to find out the combination of charges. So try and see if you can figure this out, okay? Okay guys, so anything did you think about this? Obviously, right, it's obvious from the diagram that they don't have the same amount of charge, right? If they had the same amount of charge, then it would be different. Now the thing to consider is one of these charges is positive, one is negative. So because the arrows are beginning from here, ending here, so this must be positive, this must be negative, okay? So now let's say this charge is Q1, or let's call this Q2, let's call this one as a Q1, okay? So now, so for Q1, let us say N1 is number of field lines. So let's look at how many number of field lines we have. We are just going to count. Let's count. 1, 2, 3, 4, 5, 6. So there are 6 number of lines that's ending on charge Q1. Okay. So let's see for N1. and we know now the sign is negative, right? Because these charts, the arrows is going, the lines are ending in that chart. So for, I'm going to erase this question here, okay? For Q2, let's count the number. Let's say N2 is the number that represents, N2 be the number, N2 represents the number of fill lines in Q2, okay? So let's count the number, okay? Now we forget as if this part does not exist, okay? We forget completely, and now let's just look at Q2. So let's count. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, okay? So N2 is 12, alright? So, and now we know sign is what? Positive, right? Sign is positive here. Because this, the arrow, these fill lines are originated at Q2. So now how to find what's the difference? So let's divide, take a ratio N2 by N1. So next step N1, this gives us what? 12 by 6. Okay? Right? So this is what? 6 equal to 2. So this tells us what? N2 equal to 2 times of N1. So now this is just, we use this to find the number. So we can say N2 number of fill lines here at Q2 is twice that of the number of fill lines at Q1. So we can conclude that the charge Q2 is equal to 2 times of Q1, okay? This is the twice that, but remember negative sign, okay? But, and you want to write that down somewhere, so, but Q1 is negative, okay? So that's it, alright? So this is the way to find. So we can say whenever we have this more fill line, it means the amount of charge we have there is larger, okay? This is obvious now, right? Because we found that the Q2 is twice that of Q1 basically, and now and then you do want to see the arrow, right? These arrows are also important to tell us the sign of these charges, okay? So please take a moment to go through this one and then see if you if you understood this. Alright guys, so I have this, okay. I'm going to prepare this in another video.